All right, so lesson 30, applying transformations to the parabola, determining the minimum and maximum. Now I'm going to pause here for a second so I can pull up the questions that we're going to get. All right. Let's see. So a transformation is a change in the location or shape of a graph. One type of transformation is a shift, otherwise known as a slide. And that's all we're really doing here. Now, like I've said before, with how this is typed up, we do understand that the caret symbol means squared, right? We normally see that above it, so hopefully we can read that. So in the vertex form, and I think we've already covered vertex form in here, correct? Okay, so we're getting that y equals a. Then we get x minus h squared plus k, shows the values of a, h, and k. An example of this would be where we get y equals x minus 3 squared plus 0. What that tells me is that 3 is to the left of the origin. So we're going 3 to the left on the x-axis, and we're not going up at all. Okay, so that's a shift to the left from the origin. Because our parent function, which is y equals x squared, has my parabola just like this, where the vertex is at the origin. So if I have minus 3, I'm taking that, 3 to the right. So I'm going to go 1, 2, 3, and I'm going to get that same graph to the right. Okay? Minus 3 of the x is to the right. Do we follow that? Okay. Now, if we do the same thing, but in this case we do x minus 0, right? That means I'm not moving left or right at all, but plus 4, that means I'm going up 4, right? So 1, 2, 3, 4, right? And I'm staying on the y-axis, but I'm just shifting it up, okay? So x plus or minus. X minus is to the right, x plus is to the left, plus k is up, minus k is down. Okay, and so we can actually do both of those things at the same time if they fall into the equation that way. Okay? All right. So the graph reveals that the vertex of the parabola is given by h and k, those numbers. Notice that compared to the parent function, h indicates a horizontal shift, right? We are moving to the left or right, h, whatever it is. And k indicates a vertical shift of the vertex of the parabola from the origin, either up or down. So the axis of symmetry is a line that divides a figure into two congruent mirror images. Therefore, the reflection of each point on the left-hand side of the parabola is located on the right side of the parabola. Parabola is always symmetrical. Okay? That U shape is always symmetrical. All right, the sign of A. This is important because we haven't really dealt with A yet in terms of the vertex form. The sign of A in f of x, or even y equals a times x minus h squared plus k, tells us whether the parabola opens up or down based upon whether or not it's positive or negative. If it's positive, it opens up. If it's negative, it opens down. Okay? So when A is positive, opens up, vertex is the low point. So what we're saying with that, with the vertex being the low point, is that wherever the vertex is the lowest point on the parabola. Okay? If A is negative, right, then it's going to open downward, and my vertex is going to be the high point on the parabola. That's as high as it gets. So basically what my vertex is representing in those places is the minimum and maximum of the parabola. And that's going to be important whenever they start asking things about what is the range of the function, right? Because in this here at the right, we're seeing y is greater than or equal to whatever the y value is. Over here, y is less than or equal to whatever the y value is in my parabola. Okay? And because it's a parabola and it's going as far as it can to the left and right forever, in each of these cases, yes, the domain is all real numbers. Okay? So if they start asking about those parts of a function, that's what we're seeing. But what I want you to understand is what we're talking about when we say minimum and maximum based upon how it opens. All right, so here's a a basic graph I was able to put together. All right, so we got minimum and maximum values. When it opens up, the domain is all real numbers. The range is all values greater than or equal to the minimum. That's what you see on the left. If it opens down, the domain is still all real numbers, but the range is all values less than or equal to the maximum. Okay? And we're just using x squared and negative x squared to represent a there. Okay? This next part is important because it doesn't just deal with the sign in front of the a, but it deals with a itself. The absolute value of a, right, and it does, a is in the equation, tells whether the parabola is either compressed or stretched in relation to the x-axis, whether it's pulled to the x-axis or pushed away from the x-axis. Okay? So compressed, pushed, or stretched, pulled away from the x-axis. So when my a is less than 1, absolute value-wise, because it can be positive or negative, all right? When it's less than 1 and greater than 0, right? That's referring to a decimal or a fraction, right? The parabola is pushed towards the x-axis, meaning that it's getting wider, right? Both sides are pushed down towards the x-axis. So here's where it seems a little funky, but if I get a fraction of a value less than 1, my graph is going to be wide. It's going to look bigger, okay? But if it is a number greater than 1, anything greater than 1, it's actually going to get compressed. It's going to get closer and closer to the y-axis, right? It's going to get pushed away from the x-axis. So that's the difference between what you see with the blue, where let's say we had something like a was 1/10, okay? Just for an example. If we had f of x equals 1/10 x squared, it's going to be really wide. All right, let's look at an example of this. Let's clear this out. Y equals, let's say, 1 divided by 10 x squared. Let's just graph that. See what we get. See how wide that is? Okay. Whereas, what if we did y equals 10x squared? Right? That should give me a really tight, right around the y-axis. Okay? That should be the difference between 1/10 x squared and 10x squared. Okay? So when in doubt, plug it in your calculator, graph it, check it. Okay? And then what we have with our really light gray line is the standard parent function, what it would normally look like. Okay, with no compression, no stretching, nothing being done to it. And of course, we haven't changed the vertex. We haven't slid it anywhere. Okay, all we've done is applied changes to the a. So 1/10 x squared is wider than the parent function, and 10x squared is narrower than the parent function. Okay. All right, at this point, let's look at some questions here. All right, so question number 1, we want to describe the transformations of, and it says gx, that'd be the same as y equals x minus 7 squared plus 6 relative to the graph of the parent function. So the parent function always has a vertex at the origin, okay? So just looking at this, because we have all these different graphs, what is x minus 7 doing? Is it moving it to the left or to the right? No, it's to the right. It's opposite of what you think, right? The x is always opposite of what you would normally think it to be, all right? So we're moving to the right 7. What is the 6 doing? Going up 6, all right? So the parent function is the dotted line, the thing that just kind of looks, where it should be, where normal is, okay? Standard, all right? We want to go to the right 7, up 6, okay? Do we have anything that looks like that? Remember, g of x is the transformation. F of x is the parent function. I'm guessing that we can go ahead and eliminate a and c, correct? Because those are both to the left and down, right? Okay. So we want something that's to the right and up. Okay, both those graphs, don't both graphs look like the same thing? Okay, so we're going to have to go into the description. G of x is f of x translated 7 units to the right, 6 units up. That's what B says. D says g of x is f of x translated 6 units to the right, 7 units up. So they're really close, but there is a difference, right? Which one is my correct answer? B. Good. Okay. All right. 2, tell whether the graph of the quadratic function y equals negative x squared minus 10x plus 1 opens upwards or downward. Does anybody know? Is that going to open up or down? Down. Why? Because a is what? Now, we already know we can eliminate these two options, right? But what's the difference between a and b? Right, the less than or greater than sign. Because it's negative, a is what to 0? Less than 0. Okay, does that make sense? Hopefully, a little bit. Okay. Okay, now, it says order the functions from narrowest graph to widest graph. So what we're looking for is we're looking up here first, okay? Now, keep in mind that we're talking about the a value tells me whether it's wide or narrow, right? Okay, and when we're talking about the a, we're talking about the absolute value of a in its relation to 1 and 0, okay? So a fraction, does that open wide or narrow? Okay, so we have wide here. Okay, what about negative 2? Is that going to open wide or narrow? Narrower, because the absolute value of it is greater than what? What is it? Greater than what? Greater than 1. Okay, and what about h of x equals x squared? What is x squared in this? It's the parent function, so it's the standard, right? Both of these are in relation to the parent function. Okay, so keep in mind that we want to look at from narrowest to widest. So we want our order to be, what, negative 2x squared first? Narrowest to widest, right? We want narrow, and then we're opening a little bit wider. What's the next widest? X squared, my parent function, and then wider yet is negative 1/3. So yeah, it should be C right here, correct? Okay. So this makes some sense to us. And if we needed to, what could we do to check this? Plug it in your graphing calculator, hit graph on all three. And when your calculator graphs multiple quadratic equations or just any equation, it's going to show those lines in order that you put them in. All right, so it's going to draw the first line, because you can fill in multiple graphs, you know, just like what, here, let me turn it on, I guess. You know, if we hit Y and then I hit graph again, well, it's already done it. But it's going to do the first one, then the second one. If I fill them all in from here at the same time, and then I hit graph, it's going to draw the Y1 first and then Y2 second. So if you're trying to keep track of which one was wide and which one was narrower, look at the order that it draws it in. Okay. Okay, 4, not letting me do anything here. Okay, identify the graph of y equals negative 1/2 x squared. The parent function is y equals x squared is the dashed curve. Which direction is my graph going to open? Is it going to open up or down, Jewel? We're looking at, oh, there it goes and starts doing a bunch of stuff. Let me get back up to it. We want to look at this right here. Is that going to open up or down? Down because of the negative, correct? Okay. Let's see. Allison, is it going to be wide or narrow? Wide, because of what? Less than, it's a fraction less than 1. Because if it's a fraction greater than 1, right, we can get those, right? It's still going to be narrow, okay? All right, so don't just think just fraction. Think greater than 0, less than 1, okay, absolute value-wise. So it's going to be narrow, and it's going to be opening down, okay? Which one of these is narrower than the dash, or sorry, wider than the dashed line and going down? What do we think? B. B is wide and it's down. D is pretty much the same as the parent function. Okay, so that's what we'd want there. And I don't know, here, I want to do this. What question was this? Number 4? I'm wondering if they're not trying to like split hairs. They say D, and here's the reason it's D, is because D is still wider. It's just not that wide, right? If we were to go in and graph in negative 1/2 x squared, we wouldn't find it quite this wide, okay? So this isn't meant to be exactly the same as my parent function. It's hard to tell just visually. So you'd probably want to go in and graph it and check and see. It is wider. You can kind of tell the more that you look at it. Okay? I wish it was a little bit more obvious. You know, I wish that they'd gone with 2 down, but 1 being narrower than the parent and 1 just being a little bit wider and being able to look at the difference between those two. But they're trying to be very specific. Okay. Let's see. You guys are out of here at what, 36? So do we feel like we understand the concept to this a little bit? Okay. Let's do number 6 and then call it good. Here we want to graph the equation of the parabola shown. Now we're going to go based upon the premise that this is doesn't have any change in terms of wide or narrow. Okay. So we would write y equals. Okay. Is it going to be positive or negative? Positive. Okay. We're not going to change the wide or narrow of it, so we can start right with x. X what? X plus or minus? What are we doing to the vertex? It's going to be minus because we're moving to the right. Okay. Minus how far? Minus 4. Parentheses. Yeah, minus 4, but we are forgetting something. Does anybody know what we're forgetting? Squared outside my parentheses. X minus 4 squared minus 4. Let's check the answer on number 6. Oh, gosh. I don't know if we could. They're saying 6/4. That it's. I don't know that we would. I'm trying to think. I'm sure that they look at this point here and determine how wide or narrow that's going to be from there. But I believe we got our minus 4 right. Yep. Okay. Okay, and from here, just the vertex part of this, we would go to the right 3, down 4, and that's what we're going to do there. Okay? Questions? Yeah, well, once you kind of know what you're doing, it goes relatively quickly. And I'm trying to see if there's really not a lot in here. Now, I do want to be careful about that last question and see if there's anything that tells you how you can go about. I think it would be like question D. Question D does pretty much what that last question did. So looking at example 4, says find the equation of the parabola. That's something that we're going to want to be able to do. And you're going to have to look at example 4 to get it. Okay, so look at example 4. Okay, if you got questions, get a hold of me.